Welcome back to lesson 5, where we are going to explain what it means for a function to be continuous. For a function to be continuous, three things have to happen. The first thing is, if I want to say that the function is continuous at C, the function needs to be defined at C. So at the point Z exists f of c. So this is the first condition. The second condition, if you want a continuous function, is that the limit when x approaches c to the right or to the left, the limits when x approaches c, the limit exists. And the third condition is that this limit is exactly f of c. So if the limit when x approaches c of the function f of x is the value of the function at the point c, we say that the function is continuous. Well, we know we have seen this during the class, limit from the right, from the left, the greatest integer, and the intermediate value theorem say that when you have a continuous function over a closed interval a, b, where f of a is different than f of b, and you have a function, let's say this one, it says that if this is f of a, and this is f of b, and the function is continuous, for every k that you choose on the image exists at c such that f of c is equal k. For any k between f of a and f of b exists at c on the interval a comma b, on the closed interval a comma b, such that f of c is equal k. This is named the intermediate value theorem, and is a difficult theorem to prove that needs a lot of topology. Let's go to see, well, if f is continuous and g is continuous, the sum is a continuous function. The difference, it will be a continuous function, the product will be a continuous function, and f divided by g will be a continuous function with the condition that g must be different than 0. And the composition of two continuous functions is continuous. Okay, let's go to the problems. So this we have seen a remarkable discontinuity. If you remember, the limit when x approaches 0 of sine of x divided by x, this approach 1. So the function sine of x divided by x is some kind of function that at x equals 0 is not defined. But the value of the function when x is different than 0 is something like this, and this is the function. Okay, this is the function, but it's not defined at x equals 0. So this function, this one, is not continuous at x equals 0 because three conditions needs to happen to be continuous. The first condition, f of x0 must exist. In this case, it doesn't exist. The second condition is that the limit when x approaches x0, in this case the 0, of f of x exists. This limit exists when x approaches 0 and is 1. And the third condition is that this limit should be f of x0. Of course that the third condition doesn't work because the limit when x tends to x0 is 1, but the value of the function x is equal to x0 doesn't exist. Does not exist. This value does not exist. F of x0, f of 0, f at the point 0 doesn't exist because division by 0 it's not allowed. Okay, so we have done this problem, application of the intermediate value theorem. So this is to find the roots of a polynomial applying the intermediate value theorem. We have seen this at class. And let's go to the problems. To do the problem. Find the limits, the following limits. Find the limits when x approaches 0 of absolute value of x divided by x. The function absolute value of x is this one. When x is positive, the value is x. When x is positive, let's say 3, the value, absolute value of 3 is 3. When x is 4, the absolute value is 4. When x is minus 4, the absolute value is 4. It's a V-shaped function. So this is the absolute value b of the function. What will be the absolute value of x divided by x? So for the right side of the axis, the absolute value of x is x. Divided by x will be 1. So for the right side, I will have a 1. But from the 0 is not defined because I cannot divide by 0. So it's 1 for all points except at x equals 0. For this side, for the left side, the absolute value is positive, but x is negative. So the division between absolute value of x divided by x is negative 1, and again is not defined at the point x equals 0. Is this function continuous? Well, can you draw these functions without taking your pen out of the paper? No. So this function is discontinuous, and the discontinuity is at 0. Because when you find the limit when x approaches 0 plus, it will be 1. But when you do the limit when x approaches 0 minus, from the left, it will be minus 1. So the limit doesn't exist. So this function is not continuous. But the problem is asking only about the limit when x approaches 0 plus. When x approaches 0 plus, the limit will approach to x, absolute value of x divided by x will approach to 1. It will approach to 1. So when you approach through this side from the right, 0 plus, the limit will be 1, even if the function is not defined as 0, because for the limit it's not important if the function is defined at x equals 0. What is important is what the function wants to be at x approach 0. He wants to be 1 all the time. Okay, second problem. Let's go to read the second problems and let's go to solve it quickly. It says, find the x value, if any, at which the function 6 divided by x is not continuous. Which of the discontinuous are removable? Well, the function 6 divided by x is an hyperbola, and it does like this. 6 divided by x does like this. As you see, at x equals 0, the limit exists or doesn't exist. At x equals 0, first of all, at x equals 0, the function have a value? No. No, because at x equals 0, 6 divided by 0 is not defined. So f of x0 is, to be a continuous function, we need that f of x0 to be defined. In this case, f of x0 is not defined. The second condition that we need to have is that the limit exists. But the limit when x approaches 0 plus and 0 minus is plus infinity or minus infinity. So the limit when it's plus infinity means that doesn't approach to a fixed number. So, meaning that the limit is plus infinity doesn't mean that the limit exists. It means that it doesn't exist because it doesn't approach to a fixed number. So for this function, 6 divided by x, he will not pass the first condition, he will not pass the second condition, and for sure the third condition is impossible to satisfy because f of 0 doesn't exist. So conclusion, this function is not continuous at x equals 0 because it's not defined, because x equals 0 is not in the domain of f of x. X equals 0 is not contained in the domain of f of x 0, of f of x. The discontinuity is not removable in the sense that you cannot assign a value to f of x0 that will glue the two parts of the function. You cannot assign a value at x equals 0 that will glue this part with this part. Not possible. So the function is discontinuous and the discontinuity is not removable. Let's go to another problem. Find the value x at which the function f equals x squared minus 9 is not continuous. Which of the discontinuities are removable? Well, the function f of x equals x squared is this parabola. What will be x squared minus 9? Is the same parabola going down 9 units. So is this function. Is this function continuous? Yes, of course. First of all, you can draw the function without taking your pen out of the paper. So this function is continuous, but it's continuous because at any point x is defined, any point x0 is defined a value, f of x0. And now if you approach from the right or from the left, the limit wants to be f of x0, so it's continuous. The other thing is that a polynomial is always a continuous function. Any polynomial that you write, x cubed plus 3x squared plus 2x plus 3, this polynomial, this function, is always continuous. Let's go to the other problem number 6, I think. Find the x value of the function, if any, at which the function x minus 6 divided by x squared minus 36 is not continuous. Well, it's not continuous at which value? We have to, first of all, if x equals 6, 6 squared minus 36 would be 0. So the division by 0 doesn't exist. That means that the value of the function is not defined at x equals 6. And the other point where it's not defined the function is at x equal minus 6. So what is this function? What is x minus 6 divided by x squared minus 36? Is this function. Is this one where at x equals 0 you see a white point is because it's not defined at x equals 6. So it has a discontinuity. And when x approaches minus 6 from the right, minus 6 plus goes to plus infinity. When x approaches minus 6 negative from the left, it goes to minus infinity. So this discontinuity is not removable, but this discontinuity is removable. To know what value we have to assign at x equals 6, we do this operation. X minus 6 divided by x squared minus 36, which is x minus 6, equal x multiplied by x plus 6. This will cancel and this will be equal 1 divided by x plus 6 if x is different than 6. So what value I will consider at x equals 6? The limit of the function wants to be this value. So when x equals 6, this value is 1 divided by 12. So the discontinuity at x equals 6 is removable if you assign the value 112 to x equals 6. And now you find 2 points. The x equals minus 6, the discontinuity is not removable. X equals 6, the discontinuity is removable. Let's go to the next problem. Next problem is very similar, is discuss the continuity of the function x squared minus 1 divided by x plus 1. So I do the same decomposition of the fraction x squared minus 1 is x minus 1 multiplied by x plus 1 divided by x plus 1. So this is x minus 1. So the function is x minus 1 if x is different than minus 1, because you see this cancellation, x plus 1 divided by x plus 1 cancel. When x plus 1 is 0, when x is minus 1. So this division is valid, is x minus 1 when x is different than minus 1. So what is x minus 1? X minus 1 is a rectilinear line, is this one. So, but is this one is not exactly a rectilinear line. It's a rectilinear line, but at x equal minus 1 is not defined. You see the white point is not defined. What should I do to remove the discontinuity, to make it removable? I will assign the point f minus 1 with each minus 1, minus 1, minus 2. As I assign the value of minus 1 to be minus 2, and I remove the discontinuity. So there is a discontinuity at x equal minus 1 because f of minus 1 doesn't exist. If you plug in minus 1 here, the denominator will be 0. Division by 0 is not allowed. And the second part is that the discontinuity is removable if you assign the value of the function f minus 1. This value is not defined the function, but you will assign a new value to f equal minus 1 that will be minus 1, minus 1, minus 2. And now the function is continuous if f of x is equal x squared minus 1 divided by x plus 1 when x is different than minus 1. And f of x equal minus 2 when x equal minus 1. When x equal minus 1 is not defined, but I take this value, minus 2. And now the function is continuous. Let's go to problem number 6. Discuss the continuity of this function, the square root of 49 minus x squared. The square root of plus square root of 49 minus x squared is the upper semicircle of radius 7. Is this upper semicircle. So the function is defined at any point between minus 7 and 7. If you try to choose a point like 10, for example, 10 squared will be 100, 49 minus 100 will be negative, and the function will not exist because a square root of a negative number doesn't exist. So we need the function to be between minus 7 and 7. And in this interval, the function is continuous. So it's continuous on the open interval minus 7, 7. Now, if you approach to 7 from the left, 7 negative, minus 7 negative from the right, from the left of 7. If you approach, what value will take the function? Will take the value 0. The y, if you approach the y will become smaller and smaller, and when you are very next to the 7, the value of the function will be 0. So when you approach to 7 minus, to the point 7 from the left, this is the minus, the limit is 0. When you approach to minus 7 plus, from the right, minus 7 plus is going in this direction. When you approach through here, minus 7 plus, the limit is also 0. So the function is also continuous on the interval minus 7, 7 close interval. Let's go to another problem. Explain why the function f squared has a 0 on the interval 0, 1. To explain this, we use the intermediate value theorem. So, what is f of 0? F of 0 is 0 squared plus 6, 5 by 0, minus 3. F of 0 is this. F of 1, what is 1 cubed plus 5 by 1 minus 3. So it's 1 plus 5 is 6, 6 minus 3 is 3. So I have a function that is defined on the closed interval 0, 1, 0, 1, and the value of f of 0 is minus 3, minus 1, minus 2, minus 3, and the value of f of 1 is 3, 1, 2, and 3. So the function does like this. So what it say, the intermediate value theorem? It say exists a C, this C, such that f of C equal k. K is between f of A and f of B. F of A is minus 3. F of B is 3. So exists a K between minus 3 and 3, exists a C such that for any point here that I will take in the image, it will exist a C. For example, if I take this point, it will exist a C here that f of C will go to the point K. So I choose this point, the 0, as my K. So exists a point Z, f of C, whose value is 0. So it means that the root of this polynomial exists. The theorem doesn't say how to find this number C, but it says that exists. So applying the intermediate value theorem, we found that between 0 and 1, because f of 0 is smaller than f of C, that f of A, that minus 3, exists a point C such that f of C equals 0. Okay. Let's go to the next problem. It says, explain why the function x squared has a 0 in the interval 0 pi. It's more or less the same thing. We apply the intermediate value theorem. The intermediate value theorem says if you have a closed interval and you have a continuous function, and it happens that f of 0, f of A, and f of B, pi, f of pi, they have different values, and in the middle there is a continuous function, so always will exist a point A, f of A, B, f of B. Between f of A and f of B exists, for any k that you choose, exists a C value such that f of C will be the k. F of C will be the k. So, applying the theorem, the intermediate value theorem, we see that f of 0 is minus 3, f of pi is 8, and by the intermediate value theorem exists a k, which I choose to be 0, between f of 0 and f of pi, such that f of c equals 0. Let's go to the next problem. True or false? It says the function f equal absolute value of x minus 1 is continuous on the interval minus infinity to infinity. Okay, the function x minus 1 divided by the absolute value of x minus 1 divided by x minus 1 is this function. This function is the same value, is the same function, absolute value of x, which is the v, move to the right 1 unit. So is this function. So if I divide this function by x minus 1, I divide it between himself. If x minus 1, if x is bigger than 1, I divide it x minus 1 between x minus 1, so it's 1. If x is less than 1, for example, x equals 0. 0 minus 1 is minus 1. Absolute value of minus 1 is 1. 0 minus 1 is minus 1. 1 divided by minus 1 is minus 1. So at x equals 0 is minus 1. So for all points, the value that takes this function for x less than 1 is minus 1. Is this function continuous? No. Why? Because the limit when x approach 1, when x approach 1 to the right, the function wants to be 1. And when you approach 1 from the left, the function wants to be minus 1. The limit doesn't exist. And the value of the function at the point x equals 1 is also not defined. So the function is not continuous. Okay, so false is not continuous. Discuss the continuity of the function f of x equal minus 2x plus 3 when x is smaller than 1. When x is smaller than 1, here is 1, minus 2x plus 3 is this rectilinear line that when x equals 0, the value of the function is 3. So it's this rectilinear line with a slope minus 2. For x bigger than 1, the function is x squared. So when x equals 2 is 4. When x equals 1 is 1 squared. So is this function continuous? Well, we need to see what is f of 1. When f of 1 is 1 squared according to the second rule of the definition of the function. What is the value of the function when x approach 1? What is the value? When x approach 1, the function wants to be also minus 2 by 1, minus 2 plus 3. Wants to be 1. Oh, so at x equals 1 happen two things. The first things, the limit of this function that is defined when x equals minus 1, when x approach 1 negative, 1 from the left, when x approach the function wants to be 1, because minus 2x multiplied by 1 is minus 2, plus 3 is 1. And the limit when x approach 1 positive, when it approach 1 positive, the value of the function is this 1, because it's x bigger than 1, so it wants to be also 1. So the limit have the same limit, so the function is continuous. In fact, you can draw the function without taking your pen off of the paper. So it's continuous. And now let's go to analyze this problem. Is this function continuous? Well, to the right of the number 2, the function wants to be minus 2. To the left of the point 2, the function wants to be minus 2. To the right of the point 2, the function wants to be 1. So this function is not continuous. Here at the point 2, going from the right of the point 2x equal to going into the left, going to 2 positive to the left, the value of the function wants to be a value that is different than the value of the function when you go from the left. When you go to number 2 from the left, the value of the function is completely different. The limit approach to 2 different limits, so this function is not continuous. This function is continuous, and the discontinuity is simple to remove. Just assign f of 2 equal to. If you assign the value f of 2 equal to, the function will be continuous, and you remove the discontinuity. And this one, when x approach 2, the limit will be 2 minus, the limit wants to be 2. But when x approach 2 from the right, the limit wants to be infinity, meaning that it doesn't exist, the limit. It goes to the infinity, it's an asymptote. So there is no way to remove this discontinuity to assigning a value like this example. So this function is discontinuous, is not removable, the discontinuity. Okay, you have here more problems, and let's go to you can practice this problem. Maybe you can practice something similar we have done, maybe 15, you can practice this one, okay? Or maybe you can practice problem number 40, whatever you can practice are the same problems that we have already discussed. So focus on these problems, and if you want to practice more, you can practice more problems here. So here there is a problem of inventory. So this is the inventory, the number of pieces that you have in inventory, and this is the time. So the time in month. It says that when there is at the starting point zero months, in maybe January, you have 300 pieces or whatever, maybe it's in thousand, so 300,000 pieces. So as the time passes, you are selling, and your inventory decrease, and after 6 months, the amount of inventory maybe is 20. But some merchandise come to your warehouse, and suddenly the amount of your inventory is like 120. So the question says, at the point x equals 6 months, is the function continuous? And the answer, no, it's not continuous. Can you remove the discontinuity? No, you cannot remove the discontinuity. So this part is something very similar. At here, when it happened 12 months, you increase your inventory increase, and when there is 12 months, nothing happened. The function is not defined. So when you approach to the last second of the 12 months, the value of the function is more or less 100 and maybe 50. So suddenly, in the night of December 31 at 12 months, the container arrived to your warehouse, and you start with a new inventory in the amount of 300. Is this discontinuity removable? No. And later on, the function is continuous. It decrease, and is continuous. Okay, let's go see if there are more. This is some problem about energy consumption. Problem 47 say the accompanying graph show the amount of gasoline in the tank of a car over 30 days period. When is the graph discontinuous? So you fill your tank with gas with 10 gallons. You drive, and the 10 gallons are disappearing. Maybe you drive in days. After 1 day or 2 days, you have 8 gallons. After 5 days, you maybe have 5 gallons. And after 10 days, you will have maybe 1 gallon. So, but if not on the day 10. On the day 10, you arrive to the gas station. As you approach to the day 10, you have 5 gallons. You approach, to 1 gallon. And you approach also to a gas station, and you fill your tank, and you fill it with 9 more gallons. So now your new amount of gallons that you have in the tank is 10 gallons. Is this function continuous? No, it's not continuous. Is this continuous? Because you have on the day 10, starting the first second of the day 10, you have gone to the gas station and filling your tank in suddenly in less than 1 millisecond, I would say. Okay, so the tank again goes down, and you do the same thing on the day 25. So the duration of your tank here is 15 days, meanwhile here is 10 days. But as you approach the number to the day 25, to the end of the day 24, starting the day 25, the function is not defined because you approach to the gas station and you're filling again with maybe here was 2 gallons, and you're filling with, let's say, here is 6 gallons, you're filling with 4 more gallons. The function is not defined at the day starting the day 25. Is the function continuous in the day 25? No. Can be removed the discontinuity? No, because you have to assign a value that have to fit the limit when t approach 25 from the right and t approach to the 25 from the left. And you cannot find this value that will glue the two parts of the function. Okay, this problem say in 2010 the cost P of x in cents, 44 cents, 61 cents, 78 cents of mailing a letter, weight x ounce was like this. For any letter that was the weight, so here is the weight, and here is the price, P of x, the price, so the weight is the x. So when any letter is between 0 and 1, 0 doesn't exist. So 0 is not contained in this interval. When 1 is contained on this interval, on the first interval from 0 to 1, the cost is 44. So let's say that 44 here. So the value is always 44. Even when the weight is weight in ounce, 1 ounce. So here is defined the function. But when x is between 1 and 2, not including the 1, the price is 61 cents. So the price will go like this and will be 61 cents. But here is not defined at x. Is defined, but at x equal 1 minus, at x equal 1 plus, and x equal 1 minus, the value is different. So you see that it's a discontinuous function. And from x equal 2 to x equal 3.5 ounce, the value is 78, okay. Including 3.5, excluded the point 2. At the point 2, the value is 61. So when you approach to the right to the 2 ohms, the value wants to be 61 ohms. When you approach to 2 minus from the left, the value wants to be 61 ohms. So the function is not continuous at x equal 2. Okay, let me see. There are more problems. Now discuss the continuity of this function. X multiplied by 1 plus 1 divided by x on the interval 0, 1, and on the closed interval 0, minus 1. Well, on the open interval 0, 1, the value of the function is no problem. It's not defined at x equals 0 because it's not contained. The 0 is not contained here, so the value of the function will be x plus x divided by x, which is 1. So the value will be x plus 1. So the value on the interval 0, 1 will be the rectilinear line x plus 1. We don't have to worry about f of 0 because this is the rectilinear line when x is different than 0 or in the interval 0, 1 open. So no problem, the function is continuous. Exists the limit when x tends to 0 plus. When x tends to 0 plus, the function is 1. When x tends to 1 negative, to the right, the function wants to be 2, 1 plus 1. So no problem. On the closed interval is the problem. When it's in the closed interval at x equals 0, the function is not defined. If the function is not defined at x equals 0 because 1 divided by 0 doesn't exist, then the function is discontinuous because violate the first condition for a function to be continuous. To be continuous at x equals 0 means that the first condition is that should exist the value of the function at x equals 0. Because it doesn't exist, this function is not continuous at x equals 0. On the closed interval 0, 1 is not continuous at x equals 0. Let's go to another problem. Let's go to do only the 56 and you do 57. Okay, 56 say like this. The value of the function is 1 minus 3x for x less than 4. So to the left of x equals 4, the value of the function is 1 minus 3x. So when x equals 0 is 1. When x approaches to 4, 3 by 4 is 12, 11. So the function is, when x equals 1, the function is something like this. Is when x equals 3, and when x equals 4 is minus 12 plus 1 minus 11. So the function will do something like this, and at x equals 4, this will be minus 11, and this is the rectilinear line that is defined when x is less than 4. Now I want to find the parabola, the other function that match this function at x equals 4, because this function is defined at x equals 4, to make it continuous. So to make it continuous means that I need that the limit when x approach 4 minus of the function 1 minus 3x should be equal to the limits when x approach 4 plus of the function ax squared plus 2x minus 3. So the limit when x approach 4 is minus 11. And the limit when x approach 4 positive of the function ax squared is a 4 squared plus 2 by 4 plus 3. So I want minus 11 to be equal 16a plus 4 by 2 is 8, plus 3 or minus 3? Minus 3, minus 3. So I want minus 11 minus 8 plus 3 equals 16, 8. So I want minus 11 minus 8 is minus 19. Minus 19 plus 3 is minus 16. Minus 16 equals 16a. So the a is minus 16 divided by 16, or minus 1. So the function that we are talking, ax squared plus 2x minus 3, should be the function a minus 1 minus x squared plus 2x plus 3. And now the function will be glued to the function, to the rectilinear line, and will be continuous. So this is the solution. So you can do problem 57, that is very similar. And let's see if there is more problems here. Find the limits, When x tends to minus 1, minus 1, minus 1 is minus 2. So you plug in here minus 1, it will be 1 plus 2 plus 1 minus 2, which is 1 minus 2, which is minus 1 minus 3 is minus 4. Minus 4 divided by minus 2. This limit is minus 4 divided by minus 2 is 2. So this limit, when x tends to minus 1, it tends to 2. So here is not defined the function at x equal to 1, but the limit, maybe it exists. So how we will do this problem? If we factor the numerator is x squared plus 2x minus 3. We factor using the quadratic equation, which is minus 2 plus minus v squared 4 minus 4 times ac will be a positive number plus 12 divided by 2a, which is 2 by 1. So the two values will be minus 2 plus minus the square root of 16 will be 4 divided by 2, or will be 4 minus 2, which will be 2 divided by 2, 1, and the other one will be minus 2 minus 4, which is minus 6 divided by 2 is minus 3. So the factorization of this expression is x minus 1 multiplied by x plus 3. So if you plug in this here in the numerator, it will be x minus 1 multiplied by x plus 3 divided by x minus 1. And now x minus 1 will cancel. This means that the limit will be, when x approaches 1, the limit will be equal x plus 3 equal x plus 3. When the limit approaches 3 will be 6. So this is the limit when x approaches 1. So you can do the other limits. These limits is not necessary because 1 minus 2 is minus 1. And here is 1 squared is 1. 1 minus 1 is 0, so it will be minus 1. The limit will be minus 1 divided by minus 1 will be 1. This limit will be 1, check it. And this limit goes to, when x goes to infinity, x cubed is more powerful. So you can put a big number here and you will see that this will tend to infinity. Well, you do this problem also. You practice, if you want, you practice all these problems that are very, very, very similar. We have done this similar problem. I think it's repeated. I think we have done a very similar problem, right? In each case, no. Yeah, very similar. You find the value of the constant a that makes the function continuous. b, but let's go to do the v. So x squared minus 1 divided by x plus 1. So the limit when x approach minus 1 from the left minus 1 negative of x squared minus 1 divided by x plus 1, this is like the limit when x approach minus 1 negative of x minus 1 multiplied by x plus 1 divided by x plus 1. So this limit is x minus 1. And when x approach minus 1, the limit is minus 2. So I want something that will have this value to make the function, the part b, f of x, continuous. So I need that f of 1, ax squared plus x minus 3, when it approach to the number 1, will be a by 1 positive, plus 1 positive, minus 3. So it will be a plus 1 minus 3 plus 1 minus 3 will be a minus 2. A minus 2. So I want the two limits coincide to make the function continuous. So I want minus 2 equal a minus 2. So I want a equals 0. So the value of a should be 0x squared plus x minus 3. The value of this a should be the 0, or x minus 3. And x minus 3, let me check, when x equal 1, when x equal, oh, I did a mistake here, because when x equal minus 1, let's go to redo it. When x equal minus 1, here is correct because minus 1 squared is correct, but here is minus 1 minus 3. Minus 1 minus 3 minus 4. So a minus 4 equal minus 2. So 4 minus 2 is 2. So a should be equal to, now the function should be 2x squared when the a take the value 2 plus x minus 3. And this function makes possible that when you graph the two functions, the rectilinear line and the parabola, they will have the same value at the point x equal minus 1. So x equal minus 1 is here. So I should have draw the picture from here, okay, like this. So at x equal minus 1, the value of the function, they glue the two parts, they glue this part and this part, they glue at x equal minus 1 when a is, I forgot, when a is 2. When a is 2. Okay, you can redo it. Good luck.